But with chapter 10, we're moving on to a new shape finally. We haven't yet got to talk about circles. So now's our chance to talk about circles. So, the first big chunk is a lot of vocabulary. Some terms you're probably already familiar with, but we'll talk about them nonetheless. So, the definition of what a circle is, you may think, well, it's a shape that doesn't have any angles. It's like a curvy type shape. The official definition of what a circle is the set. So a set in math we call like a collection or a group. A set of all points that are equidistant from the center or your center of your circle, which is what that first little paragraph line is. And let's see if this can reconnect. Doesn't like me. Circle. We always name it by its center. So a circle with center P is called circle P. It be written as a circle and then a P next to it. Sometimes you'll see it written as like a circle and a dot and then a P. That's also, we would say that's circle P. So circle with center P. Then we have a bunch of things we can talk about. A segment. So remember, a line segment has a starting point and an ending point. Whose points are at the center of a circle, and at any point on the circle is the radius. So the radius is something that I'm sure you know what it is, but it's a segment going from your center of your circle to anywhere on the outside. So that's a radius of your circle. It's a segment. Another vocabulary word is chord. So your chord of a circle is a segment whose endpoints are just somewhere on the circle. So we have a circle here. A chord may look like going from just one point here over to the other side here. Say chord. When a chord goes through the center point of our circle, we call it our diameter. Another word that you probably know. So a diameter is a specific type of chord that goes through the center. And then the last point, a tangent, is a line in the plane of a circle, so it's just in the same plane of whatever circle we're talking about. That intersects the circle in exactly one point, and we call that the point of tangency. So a tangent, maybe it would look like we have our circle here, and our tangent just goes by and only intersects it in one spot. Think of like the word, like you say, if you're like having a conversation, you go off on a tangent. It's kind of one thing was related, now you're at completely something unrelated. Where in a tangent of a circle, you're there for one point, but then you're off track the rest of the time. So let's go through and now use these words to label our diagram in our first example. So we're looking at AC in our diagram. C, this would be circle C, since C is our center. And going from AC or CA, that is a radius, because it goes from the center of our circle to anywhere on the outside. So AC is our radius. AB is a chord because it goes from one end of the circle to the other, but it goes through our center point C, so then it's a diameter. So those are kind of our two common ones that if I just gave it to you, I bet you could figure out. DE, like D is here and extends this way. It only intersects our circle at one point, point B. So point B would be our point of tangency. So DE is a tangent, or we could call it a tangent ray. Remember, ray has a starting point, and it goes off in one direction forever. Oh, and I skipped in the box a secant. So a secant is a line that intersects the circle at 2 points. So AG or AE is a secant because we intersect the circle at point A and point G. So secant. A secant is a line, so it goes off in both directions. Whereas if we were to stop at A and G, then this would be a chord. But since it keeps going, it's a secant. So that's just vocabulary to have. So when we're talking about things, when you're trying to refer to something, you know what to call it. You don't have to just call it this line or that line. You could say, oh, well, the secant AG, the tangent ray DE. It makes things a lot more helpful. All right, next kind of information. We're going to talk about coplanar circles and common tangents. So coplanar circle, we've had that word before. Coplanar meaning on the same plane, and common tangents. So in a plane, two circles can intersect at 2 points, 1 point, or no points. So if they're coplanar. Coplanar circles that intersect in 1 point are called tangent circles. Coplanar circles that have a common center are called concentric circles. So just in this, we can kind of see this here. We have 2 points of intersection. When we have 2 points of intersection, we don't have a common tangent through the middle. If we have 1 point of intersection, so we're intersecting at the black points, we can draw a tangent for both of the circles. And then if there's no points of intersection, we call them concentric circles. Con meaning together, centric meaning like your center. So your circles, the center of your circles are together, which because they share this common center. If it just has no points of intersection or concentric. All right, so in kind of, if you flip to the back here, we're going to tell how many common tangents these circles have. We're going to draw them all. So to make a common tangent, you're trying to draw lines that only intersect each of these circles once. So not even intersect, it kind of just touches the edge, but it is intersecting. So for A, one of my common tangents could touch right here and touch on the top of this one. So it look like this. This would be a one common tangent because it's a tangent of each of those circles and it can be the same. We can have another common tangent at the bottom of our circle going from here to here. Where it intersects right there and right there. There's another common tangent. And we could actually have two more. If you go through the middle and kind of do a little diagonal, we can have, well, here and here, it intersects in one spot. And also if we go the opposite direction, line it up a little bit better. There we go. Right here and right here. So you have a total of 4 common tangents from these. For example, B, we can do the same thing. We can have a tangent kind of on the top of your circles. And then you can have one, we want to call it the bottom. And we could have a third one that goes between the two. Think it only intersects in one spot, right? Where the two circles are going to intersect. Because if circles are going to intersect in two places, they have to be overlapping. Circles can either intersect in two places, they overlap, intersect in one spot, or they don't intersect at all. So this would have three common tangents. And then this one would just have two. The one on the top and the bottom. All right, so we'll keep going. Now we're going to introduce kind of our two big theorems that we'll work with. So our first one, tangent line to a circle theorem. So if we have a plane and a circle in it, the line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. So really, a line is only tangent if it makes a 90-degree angle with your radius. So, like here we have our tangent M. And our tangent M is making a 90-degree angle with our radius PQ. So we could kind of condense this and say line M is a tangent to circle Q if and only if line M is perpendicular to QP, which is our radius. So tangents are perpendicular to radii. Second theorem, the external tangent congruence theorem, is that if you just have two tangents coming off a circle and they intersect or they have a common endpoint, so tangent SR and ST both have a common endpoint S, then that means that SR is congruent to ST, or they're the same length. So here we're already assuming that these two are tangents, and if they have the same endpoint, then the lengths of our tangents are congruent. Getting really close to just throwing away my TV if it stops disconnecting. All right. So these next two examples, we're going to be using just the first theorem. All right. So we're first just asking, is ST tangent to circle P? So we're asking right here, I'll do it in red. We're asking ourselves, is this a right angle? Or is it equal to 90 degrees? Because if it is equal to 90 degrees, then we know it's a tangent. If it's not 90 degrees, it's not a tangent. Because we have our radius. We're looking to see if it's perpendicular to our radius. So how to check if it's 90 degrees, we could go about it a lot of ways, but I think the easiest way to do it is, right here we essentially have a right triangle. So we can use one of our Pythagorean theorems to say, well, if the squared of our legs squared together are equal to our hypotenuse squared, then it's a right triangle, which means that has one right angle at that point. So we know we can check, does 35 squared plus 12 squared equal 37 squared? We're kind of asking ourselves, is this true? Well, if you would go through and you get out the numbers, I can do it here when you're copying it down. 35 squared plus 12 squared is 1,369. And so that's the same thing as 37 squared. So these are equal to each other. All right, so if they are equal to each other, then yes, ST is tangent to circle P. And again, this is what we just went over in last unit, Pythagorean theorem, checking if it's a right triangle. So on the example right next to it, we're already given that AB is a tangent and asking us to find what our radius is. So we already know that this is a right angle. And again, I'm going to point out we have a right triangle here. So what I'm going to do now, to solve for R is one of our legs of our triangles. All right, I know how to solve for a leg of a right triangle by I can use Pythagorean's theorem. So I could say one leg, which is R, so I could say R squared plus our second leg, 80 squared, is equal to the length of our hypotenuse. But our hypotenuse right now, as it is, we know from here to our circle, A to our circle is 50. Then we have an extra R as our radius. So the entirety of the length of our hypotenuse is R plus 50. So to work Pythagorean's theorem, we have to put in R plus 50 squared. Now we're going to do a little bit of an algebra review. We haven't had to multiply any binomials yet this year, in geometry at least. So R plus 50 squared. Anytime you square a number, it's being multiplied by itself. So we take this as R plus 50 times R plus 50. And now you have to either, depending on how you learned it, you may have learned it as double distributing, as foiling, as the box method. But how you do this, if we want to do the foiling method, you take your first term and you multiply it to the first term of your second parentheses. So you get R times R, that's R squared. You take your second term, you take your first term and you multiply it to your second term of your other parentheses. So R times 50, that's plus 50R. And then you gotta distribute your second term to your other parentheses. So 50 times R again, that's plus 50R. And then 50 times 50, that's plus 2,500. So we can combine like terms here and here. So you got R squared plus 100R plus 2,500. So let's expand it out. Why we're expanding it out? Because now things are going to cancel nicely. So if we rewrite what we have, We have r squared plus 80 squared is equal to, let me rewrite in this, r squared plus 100r plus 2500. We can now solve for r. If I have an r squared on both sides, I can subtract one from the other and they cancel each other out. So let's do r squared minus r squared. They all go away. So on my left-hand side, I'm left with 80 squared, which is 6,400. And that's equal to 100r plus 2,500. And now we have to just solve for r. So once we kind of do our foiling, it's easy from here. We would get 39,000 is equal to 100r. And then we divide each side by r. So our radius is equal to 39. No more, no less. So I know for sure on the homework, there's at least a few problems where you have to do this. So if you struggle with this or need a quick review on it, let me know and I can help you out. Last problem on the back is the quick one. We're going to use our 10.2 theorem, and look it, I already have it written, so I'll just talk through what I did. 10.2 theorem, where it says if we have a common endpoint r, that the lengths of our two tangents are congruent. So we could say, using our 10.2 theorem, SR is congruent to TR. So then 28 is equal to 3x plus 4. We solve for x, so x is equal to 8, and we could plug it back in to check. Both lengths are equal to 28 units, whatever it may be. So the homework kind of focuses on all like the pieces that we did here. It focuses on kind of some vocabulary where it's going to ask you to name tangents, secants, radiuses, diameters. Then it'll go through, ask you to kind of pick out how many common tangents your diagram would have. Kind of doing where you have to solve for a radius. And then when you're going to have to solve for the length of your tangent. So the assignment's 10.1. It should be all up, ready to go. While you're working, I'm going to pass back your tests. If you don't get one back, that means you haven't taken it yet, and you need to set up a time with me to do so. All right. It's out of 42. You want to do retakes, or you got to let me know.
I never took the
Yeah.
After your class, you gotta work. Because I got or I could also.
If you come after school, that's better because I got to go down and do lunch.
Alright, yeah, that's fine.
I took off 2 days because I was on my deathbed. Sir, can you request me for work? Yeah. And you know the 6.3? The 9.6. I failed. How? What was the last unit? I did the homework.
You probably didn't have, so I just
Okay.
Make sure do not put the tests away. I'm going to collect them again a little bit. So don't do anything with it.
I'm not sure. Maybe really low. I'm gonna go there, tell them the stuff I have missing, like transfer, grade it. And then zero. Section 4 and 5. 4 and 5? I don't, you know what, when you're done after work, this is like,
Yeah.
I go back home and there's I don't know why you did that.
Alright, thank you.
I didn't have a this year, but no, I'm not dancing shit.
Let me know if you have questions about anything on the test. I can clarify. Let me put this in. Yeah. Yeah, do you want to do it this Wednesday or the retake's shorter, so I'll put you down for warrior team. Yeah.
Can I come here? Do you have anyone 6th hour?
I do, but you could take it on the pod. Okay. Do you want to do it today during 6 hours?
No,
Or
I have
later.
to practice for band.
Okay. So just later this week. Later this week, 6 hour.
Sorry, say that again.
Later this week, you want to do it 6 hour? Okay. Just let me know whatever day, and then I can always write you a pass to come up here.
Okay.